Hello, this is Eric Wamsley. I'm a systems engineer with Nutanix. Today we're going to talk a little bit about Nutanix AOS storage, specifically more about the resiliency and fault tolerance built into the system itself. The specific topics I plan on covering are our replication factor and just a quick overview of that. We're going to talk specifically about an RF2 storage container example. I'll go over some more examples of common questions, and then we're going to take a look at an RF3 storage container. As we start talking about fault tolerance and resiliency, you're going to keep hearing about RF or replication factor. So to talk about it first, just what is it? It's really just a storage container setting for how many independent copies of a data block exist within your cluster to ensure data integrity and resiliency. New writes, and this is a key thing, new writes are not acknowledged until the RF setting is met. What are the RF options? Well, there's RF2, which means there are two copies of every data block. And is also RF3, which means there are three copies of every data block. Yes, there is RF1. There's some common. There's some specific use cases where that may come up. I'm not going to review them here. Please read the documentation about it if you're interested. When we go through the rest of this conversation, you'll hear me talking about drives. I just want to point out that a drive is any storage device. This means it could be an NVMe storage device, it could be a traditional SAS SSD, or it could even be a spinning disk drive, otherwise known as a hard disk drive. Another common question I just want to go over before we dive into the actual specifics is, how is RF different than RAID? So RAID is really specifically meant to protect against drive failures inside a single system. Okay, so it's a hardware level setting inside usually a typical single server. Whereas RF, or replication factor, is a setting inside of a Nutanix cluster. And this is where data is distributed across multiple nodes inside a cluster and all the drives across all those nodes. Another thing I want to point out is AOS storage from the get-go is designed to ensure data integrity and resiliency. The fault tolerance levels are configurable and, of course, achieved by using replication factor. So let's first take a look at RF2 storage containers. So here we've got a very simple 3-node cluster. There's only a single VM. It lives up there on node 1. You'll notice the hypervisor does not matter. I've just got a general hypervisor name there. Every node has a single CVM. That's the controller VM where all the Acropolis software lives. The underlying hardware itself does not matter. In this diagram, I'm showing you a hybrid cluster. It's got two sort of SSD or NVMe drives and a couple of spinning disk drives. The example I'm about to show you, it does not matter if it's all flash, if it's all NVMe, if it's hybrid, if there's 24 drives, 6 drives, 2 drives, everything is going to be true. So let's say that VM over there, we're about to store a pretty cat picture. So it's going to write a data block. You'll see that it's going to write one local copy and one remote copy. Okay, so 1 plus 1 equals 2 because we're doing RF2. When we go to print to save a pretty dog picture, it's going to write one local, one distributed. All right, so one remote. Well, again, we have 1 plus 1 equals 2. So we've got 2 copies of those pictures stored across, as you see, all nodes and all drives in the cluster. If something bad happens, so say that second drive in the first node dies for whatever reason, that data block is no longer available. And if you look at the diagram, you'll see there's 2 copies of the purple data blocks, but only 1 copy of the blue data block. So in the back end, our system knows that, hey, there's only 1 copy and all the data in this storage container is supposed to be RF2. So it automatically reprotects the data block that is not copied, or sorry, that does not have 2 copies, that does not meet our RF requirements. If something happens after that, so say node 2 dies, right? So all those drives, all that data on those drives are no longer available. The cluster will automatically reprotect. It'll send a copy of that purple data block to another node, and it'll send a copy of that blue data block over to node 1. So now if you look, you'll see there's still 2 copies of purple, 2 copies of blue, which means we meet our RF2 settings, so we're still safe. Going to talk about a couple more common questions. One of the first ones that usually come up, especially from storage engineers or folks with a lot of storage experience, is, hey, what exactly happens if to my VM or to my data, if while it is writing that data, there's some sort of failure, right? So one key thing to note about Nutanix is, and I capitalized it, this is true, take this to the bank. Nutanix always waits until the RF requirement is met until it acknowledges writes. Okay, always. All RF requirements are met. So whether you're doing RF2 or RF3, those specific copies need to be there before it acknowledges write to the VM or the container. All acknowledged writes are persistent and durable. Another fun one is, how many failures can a cluster tolerate, Eric? Well, dear reader or listener or watcher, that is going to depend on whether you are running RF2 or RF3. So if we talk about RF2, RF2 is designed to sustain up to one full node simultaneous failures, right? So after a cluster self-heals, though, kind of like in our previous example, as long as there's spare capacity, you can actually withstand another failure. So remember, we had one drive fail, the cluster reprotected, then we had a whole node fail, and we still experienced zero data loss, and we were still able to experience or meet our RF2 requirements. If you're running an RF3 cluster, remember that means there's 3 distributed copies of your data blocks. That means you can lose 2 simultaneous copies of your data, sorry, 2 simultaneous node failures, and you'll still able have that one copy out there. That means your cluster can reprotect it automatically. After cluster self-heals, you can again withstand another 2 simultaneous failures, up to 2 simultaneous failures. Of course, since we're talking about failures, how long does a rebuild take? Of course, this is the common IT answer of it depends, right? And those variables are how big is the cluster, how big is your workload, and how much data must be recovered, right? And the really cool thing that's different from the Nutanix solution and most others out there is only the lost data has to be reprotected, right? So as an example, if you have an 8 terabyte storage device and it's only got 600 gigs of data on it, if that drive were to fail, the cluster only has to rebuild 600 gigs of data. And when we're talking about multi-node clusters with multi-drives each, that rebuild process happens pretty quickly. So another question that comes up is, can I mix RF2 and RF3 storage containers into the same cluster? So that doesn't give you RF5, but yes, you can have multiple storage containers, and each storage container inside the same cluster can have a different RF setting. Of course, you have to make sure that the cluster meets the requirements for that replication factor, of which if you're trying to run RF3, you have to have at minimum 5 nodes. So just keep that in mind. Do have a couple more common questions. One that it always surprises me when it comes up, but I guess I can see where it's coming from is, how does RF2 and RF3 impact replication? So by replication, that means from replication of your data from one cluster to another. And the simple answer is it does not. So the source and target clusters can absolutely have different RF settings. The RF setting between the two clusters is not even communicated, right? So your source cluster does not know what the RF settings are on the destination cluster and vice versa. The amount of data does not change on what's sent. So the next big one that's going to come up is, okay, Eric, if I've got that 3-node cluster and 2 nodes die, what is going to happen, right? Or if I have a 5-node that's RF2 and I have 2 nodes die, what is going to happen? The most likely scenario is going to be that if those failures occur simultaneously before the cluster can self-heal, the cluster is most likely going to read a faulted and read-only state to preserve the remaining data that is on the cluster, or to preserve that data integrity. Once those nodes and drives are brought back online, the cluster will do some self-checks and will actually automatically resume. I've seen this in person several times. So similar question, but for RF3. So say you have a 5-node cluster and you have 3 nodes go down. There is a potential that your data blocks, since there are 3 copies, were contained on those 3 nodes. So again, your cluster is going to enter a read-only state. Okay. Another common one, and this is usually happens once folks start deploying out clusters and they have their first drive failure. I just want to reassure you that because the distributed nature of AOS storage, a drive failure is no longer an emergency. Okay, so this eliminates the need for 2 o'clock on Christmas Day to go into the office just because you had a hard drive die. If you remember that demo we just went through before, your clusters automatically reprotect from any sort of drive or node failures. So while um, these things in the past may have been impactful and kind of an all hands on deck uh, situation, that's no longer the case. I also want to point out that a lot of times failures aren't really failures. It's more of the Acropolis software being more predictive in nature and trying to protect the cluster. So it actually keeps track of smart stats. So if it sees that, hey, this drive or these couple of drives are actually having too many issues or predictive read rate, read errors or write errors, it'll actually mark that drive for removal, and it basically just marks it as a failure, and it'll reprotect it in the background. I also want to point out again that since all of the HCI nodes in a cluster take part in the rebuild process, the work is spread across the entire cluster. All nodes, all drives participate in the rebuild process. So that will improve your rebuild times and the performance, thus also lowering the impact of the scenario where a single drive has failed in your cluster being actually an issue. Okay, enough words. Let's get some more words, but we're going to talk about RF3 is the word. Right, so now we have a 5-node cluster. Again, you'll notice there's a CVM living on every single node in the cluster. Okay, the hypervisor does not matter. The underlying hardware platform does not matter. I stuck with a hybrid storage solution with this example, but again, exactly the same whether it's all-flash SSD, all-flash NVMe, you have 24 drives, what have you. We do have 2 VMs in this cluster, just because you'll see with some of the examples I'm going to show you. So let's say that VM living there on node 1, it needs to write a pretty picture to storage. Since we're running RF3, that means there's going to be 3 copies of our data blocks. So there's going to be 1 local and 2 sent out to remote nodes. If that VM on node 2 wants to write some data, it'll write 1 local and 2 remote. And then again, just to have some more pretty pictures and colors, if that VM on node 1 wants to write some data, 1 local and 2 remote. Now, what happens if a drive dies? So let's say drive 1 in node 4 fails. Okay, I have RF3. It means I want to have 3 copies of every data block. I've had that one drive fail, so now I only have 2 copies. The system automatically detects that I've had a failure, and it reprotects all of the data blocks that lived on that drive. Remember, it only rebuilds the data that was on the component or components that failed. And that quickly, your cluster is already reprotected. Let's say something happens now to the CVM itself on node 2. Okay, that means that the local drives on that node are no longer available, but the VM itself is still operational. It's still running. It still has access to all the storage in our Nutanix cluster. But the data that's there, you'll see the blue and purple blocks no longer have 3 copies. So what happens is the cluster automatically reprotects it. We've met RF3. We're now good to go. We can actually withstand another failure. Of course, this must be a very Freaky Friday for this cluster because, hey, now node 1 has gone down. That means the drives and the storage blocks that are on that node are no longer available. So what's going to happen? So that VM is going to reboot on another node here, node 3. HA is going to kick in. The cluster itself is scanning and goes, hey, I've had that node go down. What data blocks lived on node 1? And it automatically checks and reprotects your data. You'll notice that my purple, pink, and blue data blocks all now have 3 copies. We've actually had multiple failures across our system, and those didn't happen simultaneously, but even if they are still going on, remember the cluster reprotected, our data is continually reprotected as well to meet the RF3 settings. So now here, we can actually withstand a whole nother node going down and your data is still available. Although now that we've only got 3 nodes fully available, we probably need to send someone into the office to look at what's going on and figure that out. So you probably may want to call support too to get a hand. So that's all I wanted to cover today in regards to AOS storage and Nutanix's built-in resiliency and fault tolerance. I hope that was helpful. I apologize if you didn't like my color choices, but I thought they were pretty. I hope you have a good day. Thank you.